What we're going to take a look at now is a 5.3 real-world problem. The question says, a controlled population of 400 insects has a half-life of 12 days. First we want to write an equation for the number of insects on t days, and then we want to find at what rate the population decreases per day. So, just kind of a few things about this problem. First thing we want to look at is really what equation are we going to use. We're given a bunch for exponential growth, decay, compound interest. Anytime that we see the word half-life, that's going to be a trigger for two things. One, that it's exponential decay. Because you're talking about a population, it decreases to half of whatever the original was in a given amount of time. That given time is 12 days here. What the formula is going to be is the one written down, A naught times B to the T over K. Just a quick reminder, A naught is the initial amount, B is the number that we're trying to multiply our original by. So in this case it would be 1/2. That may be 3 if we're tripling money, or 2 if we're doubling money. It could really be anything. T is always our time, and K is the amount of time that it takes to multiply our original amount by whatever B ends up being. So in this case, what that would end up looking like if we filled in all of our pieces, the original amount that we have is 400. We have 400 insects originally. Our B value here would be 1/2, because we know that half of the population is going to be alive after a certain amount of time. So that means the B value would be 1/2. T we don't know. And then K, what that ends up being is 12 days. That's the amount of time it would take to multiply our 400 in half and end up getting 200. So that would be 12. That piece goes here. And that would really be it for part A. That's the equation. If we wanted to, we could plug in any t value we want and find out how many insects were alive on that day. So if I wanted to find out 30 days later, I would plug in t equals 30, plug it into my calculator, and get my answer. More importantly, though, what we're going to look at is at what rate does this population decrease per day. So we're going to have to take this formula that we were given and manipulate it until it looks like this formula. Because from this formula we could see, okay, I can see what the rate is. Here I'm not sure. I have nothing that says R, nothing that is the rate. So I want to change from here to here. For the most part, some pieces are going to stay the same. Alright, the 400 should stay the same, our t value should stay the same. The only thing that really gets manipulated is the 1/2 and the 12. So what I'm going to do, and really my crucial first step here, is to rewrite this 1/2 to the t over k. What I'm going to rewrite that as is 1/2 to the 1/12 raised to the t. So I change that t over 12 into 1/12 times t. Because now I can end up doing that because of the power of a power. But now I can find out what 1/2 to the 1/12 is on my calculator. And it's a step closer looking like this, because in the exponent now is only t, like we have up here as well. So looking at this, we have our original amount and we have our t. Now we just have to try to make this look like 1 minus r. To do that, let's take a look on our calculator. Let's do 1/2 raised to the 1 divided by 12. We get an answer of 0.943. We'll round that to 3 decimal places. So we could change this all to 400 times 0.944 to the t. Now, what we have to do is we have to make this 0.944 look like 1 minus r. To do that, all I'm going to do is set these two equal to one another. Because once I do that, then I'll be able to figure out, once I solve for my rate, I can actually change it to this, and then I'll be able to kind of just work with my rate from here. So, if I subtract 1 from each side, I have negative r equals 0.056. Divide each side by negative 1, divide each side by negative 1. Oh, can't even see it on the screen. R would end up equaling negative 0.056. Now that tells me that's my rate, so I'm going to be decreasing. So what I can do is I could rewrite this formula like this to the t. This is equivalent to this, .944 is really saying the same thing as 1 minus 0.056. Now, just from knowing this equation and understanding what the rate means, our rate is not going to be a decimal, it'll instead be a percent. I move my decimal place 2 to the right. What that ends up telling me, my rate would be 5.6. So in terms of this entire question, this population decreases at a rate of 5.6% per day, and that way those 400 insects would have a half-life of 12 days.